The objective of these notes is to calculate the volume of cylinders and cones. Before discussing the objects of cylinders and cones, let's take a look at what is volume. If you'll make a note with me, volume is the amount of space an object occupies, and it's measured in cubic units. Literally, we look at the number of cubes that fills a figure. What is our approach to calculating volume? We want to take the area of the base and multiply it by the height of the object, which is the distance between the bases. So we're taking the area of the base and we're sliding it the length of the object so that we fill the object and figure out how much space it occupies. For a cylinder specifically, we are looking at, I lost an E there, 2 circular bases and a rectangular face. And so if you were to unfold a cylinder, you would have 2 circles and a rectangle. And in the shape of a cylinder, we have radius r, and the distance between the bases is the height. And that's all we're going to need to calculate the volume of a cylinder. If you generalize, what is our approach to calculating volume? If you recall from just a moment ago, volume equals area of base times the height, so a big B times h. Well, for a circle, we want to figure out the area of the circle and then multiply it by the height of the cylinder so that we can see how much space occupies the entire cylinder. For a circle, the area of the base is pi r squared. And then when we multiply that by height, we figure out the space that the cylinder takes. And so this is the formula pi r squared times h that we're going to use to calculate volume. Let's take a look at the examples for cylinders. To calculate the volume of each cylinder, you're going to use 3.14 for pi. Any number that we plug in for pi is an approximation. If you remember, pi is the most famous irrational number. So unless we kept the symbol in the formula, we're going to be approximating. So here, make sure that you have both the numbers written down, 7 and 5. The 5 is referencing the half distance from center to edge of a circle, so that's our radius. And the height of the prism, the distance between the bases, is 7. So volume equals big B times height, so area of the base times height. For a cylinder, we've established pi r squared for the base times height. And it does tell us to plug in 3.14 for pi, so 3.14. And then for the radius, we're given that it's 5, so times 5 squared, and then times 7 for the height. And if you substitute these values into your calculator, this is an approximation, so I'm using the squiggly equal, the approximate symbol. That should be about 549.5 if you round to the nearest tenth. And then we're looking at cubic units, and on this problem, it's cubic inches. And so really just plugging and chugging, we get 549.5 cubic inches. If you take a look at the second examples for cylinders, we do have a cylinder here. If you look, we have the circle is still our base because we're translating that shape of the circle, the height of the cylinder to fill it, but it's sideways, so it kind of looks funky. And we're also given the entire distance across the circle, which is the diameter. We only want half of it though for our formula for a cylinder, so half of 2.6 for the radius is 1.3. And the height, the distance between the bases, the circles, is going to be 0.74. So again, with the setup, area of the base times height, you don't always have to set that up if you don't want to, but I do need to see a formula setup of pi r squared so I know that you know that's the base times the height. And the directions told us to plug in the 3.14 for pi. We have 1.3 is our radius, and we have 0.74 is our height. And so if you multiply all of those together, we get a very small volume of 3.93. And then looking at our units, we have meters, and that's going to be cubic meters. Right here we have a cylinder and a cone. The cylinder and the cone have the same size base and the same height. And so I want you to think about how many times would I have to fill that cone and dump it into the cylinder to fill the cylinder. Let's give it a go. I lost some beads in that first dump, but there is one. Does your estimation still hold? Let's try filling it again. I just filled the cone again, and I dumped it in the cylinder. Getting close. Let's try it one more time. So not super precise pours, but you'll see that the cylinder is filled after 3 cones were filled and dumped into the cylinder. Let's translate this into how we can get the formula for the volume of a cone. From the video, we know that 3 cones fill 1 cylinder, And so then 1 cone is equal to 1/3 of a cylinder. And since we know the volume of a cylinder to be area of base times height, that means that the volume of a cone is going to be 1/3 of the base times height. The cone here does not fill up the entire cylinder, it only fills up 1/3 of it. And so really the formula that you'll be comfortable with in calculating the volume of a cone is 1/3, and then what we discussed with cylinders, which is 1/3 pi r squared h. We still have the same height. It's from tip of the cone, the vertex, to the base, the circle base, and then the radius is still the same. We're looking at the center of the circle to the edge of the circle. Let's go ahead and take a look at a couple of examples. So here we're calculating the volume of each cone, and we're going to use 3.14 for pi. Please be sure that you have the values of 5 and 3 in your problem written down, and our 3 is the radius and the 5 is the height, and so we can apply the formula straight away. So the volume for a cone is 1/3 area of the base times height. It's 1/3, if you can imagine 3D, the cone or the cylinder that surrounds that cone. And so substituting in the values that we know, we want 1/3 pi r squared for the base and then times the height. Volume then is 1/3, 3.14 for pi, directions tell us, 3 for the radius squared, and then times 5 for the height. And if you plug that into your calculator, you would get 47.1. If you haven't been trying these calculators, the plugins on your own, I would encourage you to do so to make sure you're getting the same answer as me. And taking a look at our last example, just written down, we have diameter is 6 and height is 10. And so the radius is the other piece that we need, and that's going to be 3 inches. It may help to draw a diagram to have a little cone. Make sure that you understand the 3 is that halfway distance and the 10 is from vertex to the base. And again, it's 1/3 area of the base times height, 1/3 pi r squared times h. We plug in 3.14 for pi. We have 3 for the radius squared times the height, 10. And if you do that substitution correctly, you should get rounded to the nearest tenth about 94.2 cubic inches.